Again, welcome back, ladies and gentlemen. We're now going to look at example 2 from the stretches of functions. And I decided to just change the image of the function so that if you need to pause the video. So if you look at the similar as example 2, we'll do 2a as our question. I just added the point 5, 1 to this problem. I actually like seeing a new point here, especially when we're learning about the horizontal stretches and compressions. In example A, though, we have f at 2x. Now this 2 is a k. And so what does this mean in English? It means it's a horizontal, not a stretch, because it's greater than 1. So it's a horizontal compression by a factor of, and if you take that k, which is 2, you divide it from 1, and you get 1/2. So some of you are analogous looking at the example 1 and example 2, and it's okay if you're confused. But all horizontal stretches and compressions affect the x component. Why? Because, not why. Because x is horizontal, so it's along the horizontal. Whereas stretches are vertical, stretches and compressions, they affect the y. So notice what we're going to do. We're going to really take that x and divide it by 2, or have the values of x. So notice the y values are still going to stay the same because there's no effect to that transformation. Can someone help out, Mr. Chen? What's the half of -2? Try again. Thank you for playing, Eden. But that's okay. Don't worry. Unfortunately, it's now on YouTube. Karen.
-1.
-1. Half of 2 is -1. That's correct. Half of 0. No pressure. Someone else from the class. You got to help me out. Kai.
0.
It is 0. Nicely done. Don't feel alarmed. You didn't get that one. Half of 4. Eden, you want to redeem yourself?
2.
Nicely done, Eden. See, ladies and gentlemen, Eden's a gem. She's a gem. No cap. Back to this. And last but not least, half of 5 is 2.5. So far, so good? Any questions? And again, if you're pausing the video, don't panic. Notice we decided to do this one a little differently than doing it simultaneously as the example 1. I just wanted to get the mapping technique out of the way because slowly it tends to be easier and everyone's a little different. So some people actually just start right away understanding what I wrote in English. So this point -2, 0, notice the new transformation point it's going to be. It's going to get smaller and smaller. It's going to get closer. It's going to get compressed. So that new point is that -1 and 0. And hopefully it's easier if you're doing this at home on your own graph than looking at my screen. Because again, I'm cheating. I'm actually sketching. Notice 0, 4. There seems to be no effect. And some of you are slowly understanding what's written on that handout in varying points, but we'll talk more about that later. 0, 4, no effect, right? Notice that 4, 0, this point here, it got closer. Did it get further away, right? It has to be true to the transformation. So half of 4 is 2, and that's why we got 2, 0. And then we got a half of 5 is 2.5. And notice, it should still look the same. And if you're using color or anything, if you're looking at the white graph compared to the red graph, it got horizontally compressed. To finish off the mapping technique, let me know what I'm going to do. This funny looking arrow is kind of like in chemistry. It's like you're saying it produces. So this is our inputs, the x's and y's. And I have to be careful because I'm using those letters there. So let me get my colors ready. The mapping technique helps students especially, and we'll talk more about it in detail in class. I always screw this up because I have to actually process. I actually don't use the formula myself. Let's try that again. X over k plus, I can't get my colors right, plus d. And I think a lot of you know what the D and the C are. Those are horizontal and vertical translation or shifts. The A and K, there are stretches and pressures vertically and horizontally. And that's the formula a lot of students use. Notice I literally use the K value, even though in English, this is what it means. Before we continue. That's why, in some sense, horizontal stretches and pressures are challenging.